and welcome to another ACE-based math video. Are you still trying to memorize all the values of sine and cosine for the unit circle? You don't have to live like that. Let me show you where those values come from using special right triangles. We begin with an equilateral triangle, meaning that all the angles are the same measure, and by consequence, all the sides are the same measure. And we're going to call the measure of each side x. So let's take that and chop it right in half to get this. Now we have the first of our special right triangles. Look at how special. Now this angle is still 60 degrees, but this, since it has been cut in half, is 30. And we have a right angle here. And since we cut it in half, that also means that this leg down here is not x anymore, it's x divided by 2, since it's half of what we had before. And now that we know that, we're going to use some simple Pythagorean theorem to find the values of each of these sides. So let's just call this side here h and get into it. We start off by setting up our Pythagorean theorem, and now we're going to solve for h. We're going to simplify this exponential, giving us x squared over 4. And now we're going to combine our x terms. So all I did was bring the x squared over 4 over to this side by subtracting it. Now I can combine these two terms by finding a common denominator, which in this case is going to be 4. So 4x squared over 4 minus x squared over 4 is going to give me 3/4 x squared. Finally, we'll take the square root of both sides to isolate the h, and we get this expression right here, which we can simplify into root 3 over 2. So all I did was take the square root of this, take the square root of x squared, gives me x, and now we have a value for h, which we can substitute back in here. So there you have it, friends. Now we have all the sides of this special right triangle, and in the special case of the unit circle, we know that this hypotenuse here is 1, which means that this is just 1, and this is 1 as well. So what we've done is we found the sides opposite to the 30-degree angle and the side opposite to the 60-degree angle. And that's where those values come from. Our next special right triangle is an isosceles triangle, meaning that these two angles are both 45 degrees, and by consequences, these two sides are the same size. We're going to call this hypotenuse here x, and we're going to try to find what this side and this side are. We're going to start off by setting up our Pythagorean theorem. X squared equals a squared plus a squared. Remember, you can name these whatever you want. A just sounded right to me. We're going to combine our common terms to get to a squared. We're going to solve for the a by dividing the 2 on both sides. And now we're going to take the square root of this, giving us this, which we can simplify into x over root 2, and that is equal to our a. Now, as a convention, we don't like to have the radical on the bottom, so we're going to do a quick trick to get rid of that. We're going to multiply root 2 in the numerator and the denominator, and that gives us root 2x over 2. Now we know what these two sides are. They're both root 2 over 2x. And again, in the very special case of our unit circle, we know that this has to be 1, which means that this side is just root 2 times 1, or just root 2, and this side has to be the same thing. And what we've done is we've found the lengths of the sides opposite to the 45-degree angle. Be sure to like and subscribe for more.